Recording has started. All right, everybody, thank you guys for showing up. um, week 9, you know, we have been absolutely killing it. I've really been bringing us back to kind of the fundamentals, and after kind of just doing a quick walkthrough of, full stack development here, software engineering, and um, really enjoyed the games we've been playing, so I've been created a couple more. We'll play at the end. Have two different games. One's multiple choice, the other is writing code. Nothing too advanced. Pretty easy stuff. That way we can all kind of grasp it, coders and not coders. Um, but tonight we're going to be covering the single most important building block in JavaScript. So definitely make sure we're staying up on this one. I'm going to be also dropping, of course, that mermaid sheet into the Discord resource here soon. So once that's in there, feel free to do with it what you want. Other than that, how's everybody's week been? Anybody like coding anything, shipping anything? I know I've been still dealing with this move and just trying to get through it all. And I actually had a 5K Tough Mudder that I just did over the weekend, which was really fun, but my body hates me. uh, yeah, anybody else getting into stuff like that or? Yeah, fair enough. Yeah, no, we went all like 80, 90s with it. We did like the whole crop top, short shorts and all that, and we were just covered head to toe in mud. It was a good time. Absolutely. Hey, getting on doing anything is always counts. Uh-huh. How about you, Basu? Ooh, okay, okay. Were you in the party or just attending? Hey, man. Yeah, no, after this, I'm so excited for the place we moved into is this saltwater hot tub out back. I'm so excited to hop into that after this. What about you, CJ? Everything good with you? Yeah, I feel it. I feel it. Well, that's fair, and we're still alive, so we're doing it. Yeah, hey, we've all had those moments, but we're still here. Talking, but yeah, we're gonna talk about some of the things that we that I put up in the announcement from last week. That we're gonna revisit real quick. I think it's actually kind of a mind bender when you sit with it with some of the stuff that we have and the way that we're gonna be putting all of this together. We've been using functions this whole time. So without further ado, since session 1, every console log, every map, filter, every add, event listener, all of it, they're all functions. We've written them, called them, passed them arguments without even flinching. And most of those probably didn't stop us to ask, what is actually happening under the hood here. The good thing, um, but that is a good thing, by the way. That means that they are intuitive. And tonight we're going to be pulling the curtain back, going to understand exactly what a function is, what happens when you call one, why structuring your code around them makes everything, readability, reusability, testing, interviews, everything just life easier. Eventually, you'll just start even thinking about certain life tasks like it's like it's just a function. I know I already do. um, so getting right into it, the most fundamental level. What is a function? It's a block of code that has a name, takes some input, does something with it, and gives you something back. That's it. That's the whole definition. But we are going to break each piece down because every word in there definitely matters. Let me see. Perfect. So 4 different parts for every function. A name, a block of code with a name. The name is important because the whole part of the function is that you can reuse it. You write logic once, give it a name, and then you can call that name from anywhere in your program. You're not just copy pasting the same logic into 10 different places. You write it once and invoke it wherever you need it. Um, think about it in think about this in real terms. On a project, one of the projects I'm working on, we have a function that handles calculating the price based on several options. The logic is complicated. However, you don't want the code scattered across 5 different files. You write it once, name it something clear, call it from wherever, call it from wherever a price needs to be calculated, menu pages, whatever. Call it, card it, call it, checkout summary, call it. Um, those are the powers of a function right there. It takes some input. Then you have taking some input. Those are just parameters, and we're going to dive a little bit more deeper into those in a bit when we hit parameters and arguments. Do something with it, so a body. That's actual logic. We want what we want to do. And then give something back, the output, the return value. This is where a lot of people tend to get fuzzy. So the question here, and I kind of want you guys to think about this one. What is the difference between a function that does something and a function that returns something? Alrighty. So there is a I wasn't just giving you guys an opportunity to jump in if you want. So the practical difference and why it matters. The first one is a dead end. It fires, it logs, and whatever it produces disappears. You can't do anything with it. You can't store the greeting. You can't pass it somewhere else. Can't chain it. The second one gives something back that you can use. You can assign it, you can pass it, you can test it. That distinction between side effects and return values is going to come up in in the pure function section, and again in interviews. So this is something you definitely want to bookmark to your brain. Syntax. There are 3 different ways that you can declare a function. So JavaScript, so at least in JavaScript, they give you 3 main syntaxes for creating a function. And we'll walk through all 3, and because they are not interchangeable, they each behave a little differently. So function declaration, let's see. Declaration expression and arrow, they are not interchangeable. Yeah, perfect. So the OG, the classic. Here we are. 2 things to know. Yeah, what's up? Oh my God. Am I not? Thank you for letting me know. Sharing my screen. Thank you. I'm like, everybody in the video will see it, but yeah, no problem. And here, before I go on real quick, I'll just show you the first couple slides. And again, all of this stuff will be posted in the resource tab as well. There's 4 different parts. Yeah, it feels so silly now because I was like circling these, highlighting. Yeah, yeah. So this is the ones that would fires but disappears, not assignable. These ones are assigning, pass it, test it. And then we just hit the syntax. So nothing too much on what is a function, thankfully, but thank you for letting me know. Thank you for letting me know. Um, so perfect. Declarations versus expressions. So two things to know about declarations. One, they're hoisted. That means you can call them before they appear in your file, and JavaScript won't yell at you. The engine lifts the whole function definition to the top before executing. Second, they have their own this binding, relevant when you're inside classes or event listeners. Function expressions are same idea, different shape. You're assigning the function to a variable. The key difference, though, is they are not hoisted. You cannot call greet before this line runs. Try it, and you'll get a reference error or undefined, depending on how you declare the variable. This matters more than it sounds. If you're reaching for a function somewhere in your code and getting weird undefined errors, hoisting is often the culprit. Arrow functions. A modern syntax, you're going to see it everywhere in real code bases. Here's your little arrow function. It's the, as you can see, it's the same. We're just changing how we're writing these things. Arrow functions, they are expressions, so they are also not hoisted. But the bigger behavioral difference is this. Arrow functions don't have their own this. They inherit it from their surrounding context. This sounds abstract, so we'll make it concrete. On our WTWR app, our What to Wear app, we had event listeners. And inside a regular function, this refers to the element that fired the event. Inside an arrow function, this refers to whatever this was outside the arrow function. Usually a culprit, or usually the component or module scope. This is the most common source of bugs for people coming from older code bases or tutorials. You switch from a regular function to an arrow, and suddenly your this.setState stops working. But now you know why. So as you code, because I know right now you're the only other coder in here right now, CJ, what syntaxes do you typically find yourself reaching for the most? Yeah, I mean, like out of the three, are you writing more of a declaration or an expression? Expressions like this? Fair. I tend to write mine either like this or sometimes like that. But I'd say I primarily I think I lean more towards this, or since I'm in React, it'd be like const or no, not const, export default function, and then yeah, so I'd be exporting default function and then the greeting or whatever. It's just a different way of writing a function. So instead of writing it like this, like function greet name, you are saying, hey, I'm creating this variable, and I want this variable to have this parameter of name, and this means I want to create a function. So this is so that arrow, there's your function, and then you have the constant name, and then your parameter. Same thing. It's the same thing like over here, right? So instead of putting function right here, you would remove this, leave name, and then add those arrows. Same, but different. Same, but different. Yeah. Well, I love James Franco. um, so typically what I reach for in practice, yeah, arrow functions for for a lot of things. Because that's what you definitely see a lot of that stuff in modern React, modern Express, middleware, modern pretty much modern everything. But recognizing all three because you're going to need to be able to read code that uses all three of them. Um, yes. Um, Parameters and arguments. All right, here we are. Uh, so I guess here's another slide for the what they can all do. So the syntax, whether it's declared expression or arrow, if they're hoisted, to have their own this, implicit returns, and what they're best for. Um, Parameters. We're going to talk about the input inside of functions because parameter and argument gets used interchangeably in conversations, but they actually mean different things. Um, and we will sound a lot sharper if we know the distinction in an interview. A parameter, the name you define in a function's signature, the placeholder. An argument, the actual value you pass in when you call the function. Perfect. Parameters are in the definition, arguments are in the call site. That's the whole distinction. So arguments like inside the call site, parameter inside the function. Default parameters. Here we are. What if someone calls your function and forgets to pass a value? Defaults are a safety net, especially useful in functions that render UI. If data is missing, you want a graceful fallback, not something to crash. And then you have your REST parameters. What if you don't know how many arguments someone's going to pass? The ... spread gathers everything into an array. You'll see this in utility functions, logging helpers, and anywhere you're building something flexible. A good thing to even a good interview call out, what's the difference between a parameter and an argument? This is one that's almost too common, but people still blank on it. So definitely make sure you guys are studying, or trying to retain some of this stuff. Because we want to blow all those other suckers out the water so we get the jobs, right? Scope. What is your function what your function can see? So scope is one of those topics that sounds dry but causes real bugs. So we're going to kind of break that open. Scope is just the question, from where in my code can I access this variable? There are three levels that you care about right now. You have your global scope, your function scope, and your block scope. Global scope declared outside any function or block, visible everywhere. Function scope declared with var inside a function, usually visible inside the function. Then you have your block scope. That one is declared with let or const inside curly braces, usually visible inside that block. Examples 5.3. And so why does that matter in practice? Because because one of the most common bugs that we see, and one that I've written myself, is accidentally relying on a variable that's out of scope. You try to access something that was declared inside an if block, and you're reaching for it from outside that block. JavaScript doesn't even know it exists from there. The fix is usually either to declare the variable at a higher scope or to restructure our logic so that so the access happens where the variable lives. You know, there is a practical rule of thumb. Declare variables as close to where you use them as possible, and as narrowly scoped as the task allows. So const first, let if you have to, var almost never. Yes, yeah, perfect right there. And this is what scope would look a little bit more like in practice. So global, local, blocked. Pure functions. Alrighty. This is where things should start to click for everybody. A pure function has two rules. Um, Given the same input, it always returns the same output. Two, it doesn't cause any side effects. Or yeah, it doesn't cause any side effects. It doesn't change anything outside itself. So, quick. Why does this matter? Two different reasons. Predictability, a pure function is self-contained. You can read it in isolation and understand exactly what it does. You don't have to trace through the whole program to figure out what state it's depending on. And testability, you call it with an input, you check the output, done. No mocking external state, no setup, teardown. This is why functional programming patterns become so popular in React. The more your logic lives in pure functions, the easier it is to test. A real talk on this one, you're not going to make everything pure. Side effects are necessary. API calls, DOM updates, database writes. But when you write something as a pure function, do it. And when you can, do it. It'll make your future self so much happier. Predictability and testability. I forgot to click on that one. Other than that, yeah, some closures. Save the spicy one for last, I guess. The thing that trips everyone up in interviews, and the thing that we've already been using without knowing it. And here's the definition. A closure is when a function retains access to variables from its outer scope, even after that outer function has finished executing. Even after the outer function has finished executing. The weird part here is that normally when a function runs and returns, everything inside it is gone, cleaned up by the garbage collector. But if the inner function has returned or stored somewhere, it still has a reference to those outer variables. They don't get cleaned up, and that's closure. So, like right here, make counter ran, it's done. But count is still alive because the inner function is holding on to it. Think about how powerful this is. You created a private state without a class, without this, without anything complicated. The count variable is completely inaccessible from outside. You can only interact with it through the return function. So where have you already seen this closure in the wild? Use state in React, the setter function. Let me see. Yep, the use state in React. The setter function holds a reference to state from the hook closure. Event listeners, the handler function closes over whatever variables were in the scope when it was created. Are the code dojos that we do the functions we wrote last session that I dropped in for you guys to do. Several of those were closures, whether you guys realized it or not. A good interview call out, like if they're like, hey, explain what a closure is, and you might absolutely get asked that. Your answer is a function that retains access. Let me see. Yep, a function that retains access to variables from its enclosing scope even after that scope has closed. And if they push on you, give the counter example. It's clean, clear, and mentionable. Right here. Any questions on closures or anything like that before we move on to the game? So without it, the count would be going nowhere. when you return, you're taking that count and you're taking it at you're placing it somewhere so that way you can reuse that data. Otherwise the function, like, sure, it'll be counting, but where is it going? You know, so that's kind of what you're doing is you're closing it out and being able to not lose not lose your functions and your yeah, your values. Yeah, return. Yeah, no problem. Mm, Alrighty. So some before we hit the games, I'm gonna show you the why of everything we just talked about tonight in one concrete example. Messy, repeatable code, the kind of thing that happens when you're building fast and not thinking about reuse. Um, Now after tonight, things will look like this: clean, reusable functions. So get price, now a pure function, testable, reusable, doesn't care about the UI. Log price handles the side effect logging, delegates the logic. Single responsibility, clean separation. This is exactly the pattern you'll be wanting to write in a professional code base. Fuck yeah! Now the games. Alrighty. So I think I have to go F11, delete that, F11 again. Perfect. Let me know when you guys have the answer. Just feel free to shout it out. Um, so this would be an example of a non-closure. So this question is at saying, what does this function return? And I think where a lot of people start to kind of get flustered is they just look straight at the code and they're like, okay, well, console log is saying hey, comma, and then name. Okay, well, if result equals greet Mike name, okay, well, it must return hey, Mike, right? But coding is so much more simple than that. What does this function return? At any point in this in this where does it say return? It doesn't. So no, undefined. So undefined because in JavaScript a function with no return always gives back undefined. Be because null is still returning something. That's the crazy part. Is even though null is nothing, nothing is still something. So undefined is saying that there's nothing actually defined by that return. Now, what is the difference between a parameter and an argument? We just went over this one. You guys should know this. You said B? You said C? And what'd you say, CJ? Oh, no worries. Do you need me to zoom it out a little bit? Oh, okay. It's B? Ooh, answer was C. Yeah, you were right. You were. Yep. So remember the parameter, placeholder. Parameter, placeholder. Argument, call site. And think of it like, so like the call site. It's like call sites and arguments. Try to think of it like, trying to find a good analogy here. Yeah, that's kind of what I was thinking. I was just trying to find a good way to say it, you know. Good. Well, I'm glad you thought the same thing. Perfect. All right, which one is hoisted? Okay. So you were half right. So you wanted it to be A and C. However, since there wasn't an option for A and C, that would logically leave you with the remaining answer of option A only. Um, so as we were going through across this one, this is where the it was saying that pretty much none of the other ones were hoisted, just this one. Yeah, here I shouldn't have closed it. Cause download stack. Right there. So declaration hoisted. Yes. Expression and arrow. No. So then if we go back to these, here's your declaration statement, and then your expression, and then your arrow. So only the first one. What gets logged? Alright, I believe it's A. Oh no, it was B. Uh, so so 10. So 10 inner can access X because it was declared in the outer function scope. Inner functions can always look up and read variables from their enclosing scope. So it reads up through there. Yeah, that's actually this is actually something that I learned. I just learned as well. By the way, I don't do these tests beforehand. I just create them blindly and then we do them together. So And I was terrible at algebra. I aced pre-calc while sleeping, but I guess I just couldn't do algebra. I think maybe I just the teacher sucked. I don't know. I mean, calc was just memorization though. As long as you can remember this formula, then you can answer pretty much anything. And I think there was like 20 or 21 formulas we had to remember, and they were all just a different variant of the other one for the most part. So like if you could memorize those, then you could pretty much do anything. And I haven't done it in forever though. I definitely don't remember them. But but it was because it was like dealing with like cosine, sine, tangent. I believe what was it, sine over cosine equals tangent or something like I don't. It's been forever. Yep. Yeah, that they always do. Bummer. Oh yeah. Oh yeah. What it what is a pure function? Yes, it is. As pure as can be. Same in, same out. What is the key behavioral difference between arrow functions and regular functions? Ooh. What do you think, CJ? What gets logged? Oh yeah, what's up? I was like, wait, what? I was like, yeah, yeah, what's up? Yeah, one and two. This is a closure. The inner function retains access to count from a counter's scope even after make count has returned. Each call increments the same count variable. The thing that always throws me is this, putting return before function, but it's possible. You're allowed to. What does this function return when called with no arguments? because a these are parameters. Arguments would go right here because this is the callback. So since there's no arguments, that's why this is empty. Yep. 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 Because name equals friend. You set this parameter. You gave this parameter a firm value. So that's why this one doesn't need arguments, because name already equals friend. So then if you put an argument over top of it, then you might have a conflict. Alrighty. What gets logged? I'm go I'm guessing C. See, so before I pull that down, so my logic behind it is, so remember earlier I was saying that this, like, so right here, this is setting a local scope. This isn't setting a global scope, and a local scope means that it will only be usable inside of this. Right now, when we run through this function, this is also what this program is saying is if true. We don't even know if run is true, because right now it's not set to anything. So, because this isn't in here, I would assume that you get a reference error because it's trying to console log something that may or may not be running. So since it can't even access it since it's a local variable. Like if this was put right up here, like above true or above the if statement, and then console log secret was inside the true, that would work, because then this would be set globally inside of the function instead of locally inside of the if statement. It would, now this would still be local to the function itself. You wouldn't be able to use secret as a global variable throughout the entire program, but you could use it as I'm doing air quotes here, a global function, even though it's still just a local function, a local variable, sorry, because it stays inside a function. I'm just saying if you move this outside of the if statement inside a function, you could then move this up inside of here, and if true, it would know what secret meant because it's defined above, rather than inside of its own block. So, yeah, const is a block scope, secret only exists inside if blocks curly brace, blah blah blah. Once outside those braces, JavaScript has no idea it even existed. Yeah. Which of these is an example of a closure? And then the real game begins. This was the warm-up. Boom, boom, boom. Killing it. Alrighty. There. And then, of course, I'll drop the games into the resource channel as well. Gotcha. Alrighty. Like I said, now we're going to actually start writing functions. Feel free to either just yell at me what to put there, or feel free to just type it into the Discord, one of the Discord chats, either the channel chat, message me, however you want to send it, and then I'll copy paste it. And if you guys need a hint, just let me know, and I'll click on the hint button. We'll test it, we'll run it, and yeah, we'll get her going. She's like, I just do UI. She doesn't even go here. So, and again, like this would be your parameter, and then this would be the argument that's going inside the callback. So if we write greet and then Mike, how are we going to get it to produce hello Mike? Same thing. So we need to figure out what will go inside to make the parameter meet the argument. Hello. Do you guys want the hint? Yeah, $sign is how you start a what's called a template literal. It allows you to use certain elements or variables inside of a string. And so instead of writing like hello comma, if you just wrote name, it would then return hello name. So in order to get it to return the argument in place of the parameter, what you would do is you would turn it into a template literal so that the code knows to read it differently. It's now saying, hey, read this parameter, which is a placeholder. And so when you write your callback, like greet Mike, the argument is now going to replace that placeholder, and it will then say hello Mike rather than hello name. Yeah, exactly. So that's exactly what we're doing right now is like even right here inside of greet where we're doing now stack squad. So instead of it being Mike, it would just change to stack squad. So it's going to be now any argument that you put inside of here because so the argument is saying, hey, I want you to replace that parameter because greet and then parameter. So variable name or function name, and then its placeholder. So then function name, and then the argument. What do you want it to actually do with that placeholder? No. What you'll see once I put the answer up. Yeah. Uh no, but yes. Because half of what you just said yes, but the first part no. It's very simple. Hit me with it. Hit me with it. It's the second hint, yeah, it's your answer is inside this yellow box and it's a combination of two pieces. Yep. What you got? What you got? Just send it over. Let's see what you got. Oh, you did? There it is. Yep, that's it. Yeah, return. $sign. Curly's. Ching, 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 ching. It was that simple. That's just how they had it written. So like you see right here where it says greet Mike, it's return Mike, yeah. Hello Mike squad, and it's just a thingy. Yeah, it was just a part of it. That's what I was telling you. I was like, you're really overthinking. I promise you are. It's very simple. That's why I was like, yeah, the first part, no, the second part, yes. Alrighty, double it. Write a function called double that takes a number and returns that number multiplied by 2. Now get this is another one where it's just gonna be a nice little one-liner. I'm not gonna give you the hint because the hint, I don't know why, the hint is straight up giving you the answer. So I can't do it on this one. Mm, it's as easy as it sounds. It's just when you look at it and then you're like, well, how do I write something like that? Your head just starts to scramble. Um, it's just and that's exactly why I wanted to start getting back to the fundamentals and doing this shit with not only with you guys but for myself because I have just as hard time sometimes. So triple ten, they threw a lot of really great information. We know a lot of really great stuff, but they dropped the ball in application because this is how every student feels. So th this is why we got this community, and we're going to be kicking ass. So. slide it my way. Yep. Yeah. I can't spell to save my life. I was like, give me. I was like, zoom in, and just like what I forget what that movie was. He takes the laptop and just shoves it straight in his face. Oh, Big Bang Theory. He was like, yeah. He was like, that actually was helpful. Like, um, but yeah. Like I said, just as simple as that. Yeah, and the hint, just return number 10 times, dude. One line. Yeah, I was like, dude, what the hell? Is it even? Write a function called is even that takes a number and returns true if even, false if it's odd. It will ramp. They will ramp up just a teeny bit. Yeah, it eventually, like, once. Yeah, you did. You did see one from last week. Great, great memory though. Yeah, so this one, so like first place that my mind goes, like where it used to go at least, is okay, well, I need to write an if statement because if it's true, then I want it to do this. And yes, you can absolutely do that. Do it this way. However, there's a much simpler way to do it, and that's what we're gonna learn here today. Um, they the hint, because if I click the hint, it's gonna again for some reason just give you the fucking answer. But it's called a modulo expression, or sorry, modulo operator. It's a different type of operator that will return true when the number's even based on a specific. Yeah. Yes, yes. So plus means to add, the minus is minus, the star, the asterisk or whatever to multiply. What does the percent symbol mean? Mm, is it? Or is the backslash division? It is not. NUM. Oh, there it is. I was like, that is actually correct. I was like, why is it saying it's wrong? So yes, this is not division. That's division. This produces a remainder. So, say for instance, you did 3 divided by 2. You get 1.5. That is going to then say that you have a remainder of 0.5. 0.5 does not equal 0, which would then produce false. Whereas 4 divided by 2 is an even number because it would then be 2. There would be 2.0, right? Like a dollar. So 0, 0. So this gives remainder. So if you ever want to find an even number, fucking that's it right there, bud. Um, to use it to find duplicates, possibly. Or, or if there's supposed to be, only X amount of things showing, possibly that too. So, yeah. Or like, yeah, it can be a lot of shit. I'm drawing a blank. You could use it with like inventory or whatever. Mm. All right. Default greeting. Write a function called welcome that takes an optional name parameter. If no name is passed, it should return welcome stranger. If a name is passed, return welcome name. Um, yep, can't show you the hint. I'll have to make up my own again. You guys have already seen this tonight. You guys have seen this actually in a couple of the. Ooh, we are not writing a declaration here. We are writing an expression. If that if that helps. Um, Still going to use we'll still use temperate literal, and we're going to write this as an expression, not a declaration. Um, Now there are a couple ways to do it. However, we're looking for the streamline answer. Like, of course, you could set, um, you know, let name equal stranger, and then put in, return, a literal, and then that would allow it to change. But because let allows change, const does not. Um, but that's not how we're going to do it. Or like I said, we've already seen it in one of the thingies tonight. Okay. So like this. And here, that would give us one extra one of those. That still doesn't solve that. Close though. I definitely see the thought process behind it. However, so if the name is undefined, okay. Okay. I see what you're, yes, I see what you were going for. Now, what about yeah, that's the equal sign. Does that help a little bit? So, what is name? What is before even before the equal sign? Pretend that's not even here, right? What is just name? Yes. And what is a parameter again? P to P. Oh, you're good. Parameter is a placeholder. Argument is a callback. Yeah. So since this is going to be our parameter, our placeholder, we're saying that our placeholder is stranger now. We're just saying that name, which was nothing, right, to begin with. We're just saying that the default now, just the default, is stranger. This is what it equals. However, when we create a temperate literal here, it's then now saying, okay, placeholder, whatever my argument is saying, this is what we need to replace it as. And when we don't have anything there, it says, okay, instead of putting just, undefined, it is now defined, saying, okay, its default value is stranger. Whereas when you put in Mike, it then will then say, okay, we have a name, Mike. Absolutely. Because you've set this as the default value now. Exactly. Or welcome adventure, when you first join a game. Take it easy, brother. Thank you for joining and staying as long as you have. Hit us up if you need anything. You too. Some all. write a function called sumAll that accepts any number of arguments and returns their sum. Use rest parameters. Bum, bum, bum. Yes. We also went over that tonight, and you may have missed that part. But I have no problem doing this, though. So, if we're talking rest parameters, because it's not like this is an actual class, we can absolutely do this. Rest parameters. Here we are. ... Gathers all remaining arguments into an array. Flexible APIs, logging helpers, utility functions. So, here I'll go back to nice. Let me go back to the thingy now. F11, this F11. And then where is my speech? And I'll reread you that part 2. Try to keep things organized. Rest parameters. What if you don't know how many arguments someone's going to pass? The ... spread gathers everything into array. You'll see this in utility functions, logging helpers, and anywhere you're building something flexible. So it's just a way to gather. Yeah. So I'll get us started. So we want to return, right? No worries. No worries, bro. So we want to return, right? Because that's what we're after in all of these. We're trying to return something. Otherwise, it's not gonna, we're not gonna have any closure or anything like that. So next, what do we want to do, right? We want to do something with our parameter. That way, when we have an argument, we know, we can do something with it, right? So we'll start with nums, and so here we're saying write a function called sumAll, perfect, function sumAll, that accepts any number of arguments, so ... nums, and returns their sum. So now we need to get them all together. So if we want to get all of those together, just kind of like the problem, or the sheet that I just pulled up for you, right? We want to reduce all of those numbers, right? Because we want to reduce the amount of numbers we have down into a single number. We then are going to want to yeah, because we can either use reduce or a loop. Let's see. There we go. No. Um, so here, I'm trying to get the breakdown of it. I've memorized this one. I just don't know how to explain it, so I'm trying to pull up a good explanation of it. Um, so before I look at here while it's looking doing this thing. So right here, right? So we are creating an arrow function, right? So right here we're saying inside this reduce so it has the numbers. We're reducing the numbers, and instead of just putting numbers inside of here, or from what I we're taking we're creating a function, right? And this function has two parameters, account and n. Account plus n and then 0, right? So it's going to the account is going to start at 0. Um, yes. So the names ACC and N they're just convention. We could call them total and current. Um, so the names don't matter, the positions do. So the first parameter is the accumulator, and then the second is always the current item. So we're saying the accumulator, we want that to start at 0, and then we're going to add n, and it's going to iterate through all of the numbers, adding n, which would then be the next number to 0. So it'd be 0 and then add n, add n, and so it loops through it all. It just so it has like depending on what it is, like this one it iterates through it 3 times. So it says 0. So it starts at ace 0, and then the first iteration would be ace 0 plus 1, then 1 plus 2, then 3 plus 3. So yes. Yeah, I was like, let me like try to pull up a way to like explain it in words rather than just like, I mean, here, like it's that you do this. Just do it. Memorize it. Oh yeah, no, absolutely, absolutely. And again, all of these games, the reveal deck, the cheat sheet that I haven't, in both games, I'll put all those in the research channel as well. I typically upload yeah. So from all of the videos I do, they're all on YouTube, and then all of the games and any resources, there's a cheat sheet for literally every single video. They're just called uh, yeah, I call them mermaids. So it'll be like if you type in like week whatever, like week 9, week 2, and then put mermaid, it'll pop right up. Yes. So I make sure to give you guys the reveal deck so you have all of the notes. So if you do miss anything, you can always recopy or just go back. You'll have the cheat sheets for a quicker view at a glance so you can study before interviews. Um, and you'll have all of the games so you can practice this stuff on your own. Just to just get it going. So there's actually 2 games in there as well from last week. Yeah, so typically whenever someone's like, oh, I'm taking notes, like they don't know. Yeah. Yeah, so for anybody watching videos, fucking email the fucking email for the weekly stack, and I'll get you added into the Discord, and you can have access to all that stuff. Um, so clamp a number. Write a function called clamp that takes 3 arguments, num, min, and max. Return num if it's within range. If it's below min, return min. If it's above max, return max. Not with reduce, but with a different method. I can give you that. So still kind of, so almost kind of like the last one where you can, we're gonna write not necessarily an arrow function, but we're going to we're gonna give it a little zhuzh. No, yeah, yeah, take it easy. Bye. So, so yeah, so we're nesting here. So math max, so we're going to take the number, the minimum value, and then on this side, so inside of here, we're taking this one, and then that one. So there's two values inside of this one, and then there's another two values inside of this one, which is here and here. So it's just taking this method as a single value, or as a single argument, I should say, and that would be its second argument. Yeah. And like I said, the game will be dropped in there, so you can go back through and try to do these at your own pace as well. So like always great to see how they're kind of done. That way you can start opening up that mind's eye of like, oh shit, this is how we actually write code, and then go back and like, okay, how did oh shit, I don't remember that verbatim, but let me see if I can figure it out now, and then that's how you'll get it to stick. So. It's all of us, man. Trust me. It's all. I love what they gave us, but like they really dropped the ball on us actually knowing how to do this. Yeah. Mm-hmm. Yeah. It almost kind of feels like I'm learning like another language. Like I've been learning German and stuff, and it's like I can read and write it. I can read it a whole lot better than I can speak it. And in terms of like, this is speaking right here. Like if I see a bunch of code, I can read it and understand it, but then you're like, oh yeah, now write me all that stuff. I'm like, get fucked. Write a function called capitalize that takes a string and returns it with the first letter uppercase and the rest lowercase. So we're just taking the word and fixing its syntax essentially. So here I'll walk through this one. So we're gonna return. We want to return our word. Now, what we are trying to do is we need to take the first letter of said word, which, if you were to have an array, how would you pick the first letter? Yes, but we use this with square brackets, right? Square brackets say we're looking for an indice, and this makes it says like, hey, in this array or this string, we want this item, this indice of 0. Now, what do we want to do with that word at the very beginning of it? There is a method, yeah, and to capitalize, that is to uppercase. And now, that's just the first letter. So after that, we need to say, okay, well, what's left, right? And that is going to be word slice. Oh, and here, let me give you a hint. Which would be 1, and then dot 2 lower case. Because right here, what this is doing, we're then taking that word. Yeah. I was like, oh shit. Yes, this works. This doesn't need square brackets because right here we're saying word, which is going to be this, right? This is going to be our word, any one of these. And it's saying we want the very first letter of said word, right? This is saying word. Now we're going to take that word, but we're going to slice it. And we're not slicing at, we're slicing at an indice, but slice is its own method. And since it's its own method, you just put the indice inside of that. Like you could even slice a range of like 1 to 5, and it will count the indices that way. But you don't have to put it in square brackets because this is its own method. Exactly. And then, so since that is 1, that now means we're starting at the second, and we're 2 lowercasing all of it. This is concatenate, concats them, which puts them together. Easy peasies. Well, and that's what I'm saying. Like when they did have us do shit, they like did not explain it in an easy way at all. Like at all. Yeah. Yeah. Write a function called count occurrences that takes an array and a value and returns how many times that value appears in the array. So we'll start with our return. So yeah, so here's the here's an array right here, and we're saying how many we want the number 2. How many times does 2 pop up? 2 times. And then the array here it's an array of strings, and we want to know how many times A pops up in that array of strings. 2. And down here 9 doesn't at all. So, and I think a lot of what writing is like it's remembering a lot of these methods, because like knowing the methods helps a lot of like of what they truly do. Like for this one, for instance, we're going to be using filter. We're filtering through the array to find that selected item. And in this term, we need to write an arrow function, right? Because we need to find the specific value. So, yes, because so right here we're saying item, so we're filtering, and we're looking for item. Item equals, oops, drag my eye over there. Item equals value, our val, okay, which would then be our second number. All right, and then we're gonna go dot length shaboing. So we're taking this array which is our first parameter. So it matches our first argument. Taking that array and we filter through it. That filter is looking for item. Item is set to value, and then dot length. Why we couldn't just do... I fucking hate when it doesn't do what you want it to do. So I hate that you can't do that. You have to set it, yeah. Well, we were... no, I wasn't even trying to use item. That's what's... See, filter, val. You can't just filter the value. Yeah. Mm-hmm. Exactly. Yeah, it's just the entire length of the array. So, because this is just filter. This is just the filter. That's one method, and then you're tacking on a second method. Motherfucker. And you're just tacking on a second method. So this is why I don't have the videos marked. This is why my videos aren't marked for children. I'm not doing anything stupid. It's just like, yeah, I swear like a sailor, man. Hey, from what I hear, swearing is a sign of high intelligence. Yeah, they say it's because your brain gets overstimulated with so many different variations of the word that you just instead go straight for the blunt force meaning. Make a multiplier. Write a function called make multiplier that takes a number factor and returns a new function. That return function should take a number and multiply it by factor. This is a closure. So write a function called make multiplier that takes a number factor. Function make multiplier factor. Perfect. And we want that to return a new function. Okay, return function. That return function should take a number. Cool. Number. It really be like that. I hate it, but it really be like that. Now, that returned function should take a number, yep, and multiply it by factor. Okay. Return num, multiply it, vector. Cool. And that's how simple some of these things can be. It really could just comes down to just reading it down, reading it out, and sometimes reading it out loud. Don't like I've gotten to that point in my life where I've realized I don't really give a fuck. You know what I'm saying? Like I don't care if you want to think of me as a retard or I'm stupid. I will sit there and read a fucking thing out loud if I have to, if that means I'm going to get it right. And and at the end of the day, you know, eventually you'll stop doing it. Maybe you never will, and that's just your little thing, you know, your little quirk. But most coders work at home nowadays, or they sit in a cubicle all by themselves. Who cares if they talk to themselves? We're known to be crazy people anyway, so. So pure format price. Sounds like we're going to be writing a pure function. So write a pure function called format price that takes a number and returns it formatted as a USD price string like $9.99. It should not log anything or touch any outside variables. So a pure function, it takes its input and produces the same output, essentially. So I'll start us with the return. What do you think we go with next? Not necessarily a temperate literal, but we would want the dollar sign. So in order to so a temperate literal is allowing us to use like a parameter or a destructured name inside of a string, so it doesn't get caught up in the way that it reads. Here we want the dollar sign, because the way that you write a temperate literal, that dollar sign doesn't appear. Like it didn't pull up hello dollar sign Mike. I mean, that'd be badass, you know what I mean? But so in this case, we're just trying to produce a new string, a new format, essentially, because we're returning it's formatted as a USD price. So we're literally just taking that number and we're just doing this to it. So we have to concat that with here, we'll start there and I'll show you why no. It passes the first test, yes, absolutely, because we have it written as $9.99, so it's able to say, okay, dollar sign with the number $9.99. However, when we get down to 10, or even down to 50 cents, we want the USD price, which includes the decimal and followed by 2 zeros or a 0 after the 5, or 50 cents. Which num doesn't do that because it's just a 10. So here it's producing just 10, got 10, got 0.5. So now we have to do something to this, right? It fixes 2 additional places to the end. Should it be missing? So it calculate. So since this already has all of its positions, it's done. So 2 fixed. So there's 2 fixed after the decimal. Now there's 2 fixed. In this case, it only had to add 1. And then here it had to add both. So it's just making sure it counts up to those additional 2 places. Yep, so use 2 fixed 2 to get 2 decimal places, then prepend a dollar sign plus number 2 fixed. As you can see why I didn't put that up right away. It's the answer again. Get initials. Write a function called get initials that takes a full name string and returns the initials in uppercase separated by dots. Like my motherfucking name, Mike Borges. And anybody watching, no, it is getting late. This is what late night coding looks like. Losing your mind. I still have to do laundry before work tomorrow too. Jesus. We'll watch some more Solo Leveling. That gives me an excuse to just stay up and watch Solo Leveling. uh, so we want to write a function called get initials. Cool. Function get initials that takes a full name string and returns. Okay. So name. Cool. So we want to return a full name string and returns initials in uppercase separated by dots. So we want to take name and we want to split that thing, right? So where we're splitting it at is at the gap. We then want to, yes, so right here. Yeah. So it's that would register the space, yeah. And then we want to map. And then again, this W is just going to be, it could be named whatever. It could be named Ninja Turtles, TMNT, you know, all the good stuffs. In this case, the W stand for, let's say, word. So we're mapping through the words and we are grabbing the first letter of those words and we're changing them to upper case. Okay. And then let's see. To uppercase. Close that. Oh. Okay. That makes sense. Let's see. No. Oh, that's dumb. I'm a dum-dum. Okay, yes, okay. I don't think that's going to... Perfect. That's now giving me M and B. So it's giving me first initials, and then we just need to... So I was missing this. Yeah, I love and hate coding at the same time. It is the little syntax things that can just screw you. So I had it sitting like this to do it, which I knew this wasn't going to give us the full thing, but I like, you know, I'm still broken. I'm trying to work through it. And so once I add this, it then fixed it, which now gives me my first initials of them, which we are still expected to do for produce m.b, right? So now that I know that we have an array of just first initials now, because like sometimes like, you know, like I don't know how to write all of this stuff out in one full-on sentence, like just full-on, like, you know, like the pros do. So like I kind of like to break my shit up a little bit. So now that I know I can break this, now I know I just need to join them, which was dots, and So join dot with dot. I did something wrong. Okay. Yeah. So this should be joining. Ah. No, that should be it. Because, yeah, we want to join. Is because we had to finish because I forgot to I didn't close I closed. Okay. Always make sure to close your methods and then make sure to close your methods. Just fuck me. so we're joining them, we're stitching with this. So we're removing that array and putting this in the middle. This is to add the trailing dot. So because we're joining initials, we just need to leave the trailing dot. It's like a for loop. It's just a way to loop through an array or a string. Yeah, no. When they teach for, that's when they should be teaching map as well, because it's literally it's just a much more productive way to write a for loop, and then that's when you then can even start getting into hash mapping, which allows for like indexed mapping and blah 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 blah. It's a whole thing. There's actually a whole video on like hash maps and stuff like that. I believe it very first video, the big O in data structures. Make a counter. Write a function called make counter that returns an object with two methods: increment, which increases the count by 1, and get count, which returns the current count. Start at 0. Use a closure to keep the count private. I believe I remember this one like fully. Not terrible. But you don't need it. You also don't need a map. So write a function called blah blah blah. We want to start at 0. So this is going to be something that changes. So we use let instead of const. Right? We want to now return. So returns an object with two methods. So increment. So the first method, increment, right? And we'll give it a little arrow function. So increment, which increases the count by 1. So little thingy thing, little arrow guy, and we're going to say that this method, we're going to say count plus plus. I messed something up currently. Right here. Let equals 0. No, let count equals 0. So now it makes sense. So we're taking the count that equals 0, and now we're saying count plus plus. we put this inside of curly brackets to make it a object, and that object can now be separated by commas. So the object, so we have two methods, two objects, one being increment, which increases the count by 1. Increment, empty function, count plus plus. Cool. Now we need to get count, and let's give it another arrow function. And so with arrow functions, remember, this is just parameters. Just parameters. If we don't have a placeholders, we don't have to have placeholders. We can just leave it up nice and empty. Which returns the current count. So, count. This closes the return statement. That closes the full function. So we're letting count start at 0. We are returning the increment, which is just equal to count plus plus. And then we're returning the get count, which then will just return whatever that incremented to. So this will increment that, and then that will return this. Easy peasy. Filter and transform. Write a function. Write a function called getExpensive that takes an array of product objects, each with name and price, and a threshold number. Return an array of the names of products whose price is above the threshold. So, write a function called getExpensive. So, function getExpensive that takes an array of product objects, each with name and price. Okay, and threshold number. So we have an array of product objects and a threshold number. So that's where our two placeholders start. Products and threshold. Now we want to return an array of names. So return an array of the names of products. So of products, price is above the threshold. So if we want to return the names of products that are above that threshold, so products, we need to look through these products, right? So the products are going, we would then need to filter through them because we already have them. And we know how many there are. So then let's create our, our little arrow function inside of here. And so we want to take whose price is above. So if their price is above the threshold, then we want to map to now go through all of these. So we're first going with, okay, products, filter through their name and see if it's above the threshold. And then we want to do that going through the entire list. So mapping P again, because it doesn't matter that we reuse P. Do you know why? It's its own function. It's its own method. So what did I misspell? Hmm. Hmm. I'm doing something wrong here. Threshold map. Oh, yeah, there was a space right there, wasn't there? Okay, got error missing thing after argument list, comma expected. Ah! And then there's a slash in there for some reason. Where is the slash coming from? Yeah, I'm fucking lost at this point. I'm pulling out the big guns here. Come on, telephono. Do your thingy, yo. So it doesn't make sense. So yeah, because products, we want to filter through them. God, phone, can you just please load? It's above the threshold. Yes. Then we want to map through the rest. Give the name. There you go. Finally uploaded. Um, Fucking asshole. Okay. Alrighty, guys. So it said that it gave me a broken one. The way that it was writing the functions or the shit in here for us, it fucked one up. Which, yeah, so we want to return products, filter through them with an arrow function of p.price above the threshold. And we want to map through those with p flipper name, and the rest of it. Run it. Boom. Thank you. Jeez. So yes, it was correct. So I pulled it up and it was saying that the way that that Claude had written the program, he used JSON stringify as the expected value for the challenge, but not the others. So the comparison broke down. So it was comparing it against JSON strings rather than an actual array. So it was, yeah, it was. So, yeah, it thought it was trying to pretty much stringify it. So. Yeah, so we're not stupid. Yeah, oh jeez. Okay. So yeah, compose two function. Write a function called compose that takes two functions f and g and returns a new function. When that new function is called with a value, it should apply g first, then pass the result to f. Excuse me. If that don't sound confusing, I don't know what do. Alrighty, so, but it is actually pretty simple. I'm trying to think of the best way to explain it. Okay. So, we got this function called compose. It's taken two functions, f and g. Got it. We want to return a new function. Let's call this function. And when the new function is called with a value. There we go. Value. Then we want to, it should apply G first, then pass the result to F. Alrighty, so then we want to return again, because we need this function to return something. So return, and then we want F. So G X. Perfect. So value. Well, the value first apply to G, and then it will pass to the result of F. We are working from inside out here. So return a function that takes this and returns boom, 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 boom. G runs first, then F gets G's result because the function gets plugged into X. So say, what is it? Double then add or whatever it was, you put in a number, 5. 5 would then get plugged into here. And then whatever happens here then gets plugged to there. We did terrible. 2 of 14. No, we killed it. We killed it. And then just to wrap up the video real quick, so I can hit stop recording. Thanks everybody for who did join and for how long everybody stayed. For everybody watching, remember to send an email, drop a comment or something, so that way I can get you into the Discord, so you have all this resource material. Otherwise, only the cool kids get it. So that's about it, and I'll see you guys next week for some more fundamental stuff that gets us really actually working and productive. So, toodles.